Right. Today we're going to be talking about special cases when it comes to solving equations. So we're going to start with the one solution. I'm going to go ahead and draw my line. Remember, we need to get our x all by itself. Right now we have an x or a variable on both sides. We can't have that, so we're going to move from the right to the left, just because this is how we're used to seeing equations set up. 6x minus 8x is negative 2x. Bring that plus 3 straight down. Equals, this is now a 0, and I'm going to bring my minus 21 straight down. Now I'm normal two-step equation. I'm trying to get that x by itself. So minus 3 on both sides. So negative 2x, that equals 0 now. Negative 21 minus 3 more, so I'm going even deeper into the negatives. Negative 24. And then finally divide by negative 2. These cancel out, leaving me x equals, the negatives cancel, and I find out that x equals 12. This is called a one solution because you're going to get one answer. X equals a specific number. Now we are going to come over here and we are going to check our work. And by checking our work, we're just going to plug that 12 back into the equation. So 6 times 12 plus 3 should equal 8 times 12 minus 21. All right, so if both of these sides equal without moving anything from side to side, then we know we've come up with the right solution. So 6 times 12, that is 72 plus 3. And we're just going to go ahead and solve this entire left-hand side, and then 72 plus 3 is 75. And now we'll come over and we'll solve the right-hand side. 8 times 12 is 96 minus 21. And 96 minus 21 is 75. So 75 equals 75, that is correct. So check, we know that the correct answer is 12. All right. Down here with number two, down here with identity, also called infinite solutions. So again, we're going to start this the same way. I'm going to go ahead and draw my line down my equal sign. But this time I do have another step I need to do. I have to start with this distribution. So putting the 2 times 5 and 2 times negative 4a. Right now, since I'm not touching the left-hand side, I'm just going to bring it straight down. Equals, and then 2 times 5 is 10 minus 2 times 4 is 8a. Now I'm going to go ahead and move my stuff from one side to the other. So I'm going to move my 8a to the other side. And when I do that, this equals 0, so I have 10 left over here, equals, bring that 10 straight down, but this also equals 0, so I just end up with 10 equals 10. So we want to notice how they're equal on both sides. It's the same number on both sides. That is infinite solutions. That means it doesn't matter what number I plug in for a, I'm always going to come up with them being equal. And here's how we are going to prove that. We're actually going to do two different equations, and we're going to plug in two different numbers to show that this is infinite solution. So I'm going to go ahead and do that just to separate my two sides. And we're going to start by plugging in the number 2. So 10 minus 8 times 2 should equal, this is a bad place to put my line. I'm going to erase that line right there. So, and I didn't even write it right. Bear with me. All right, let's try this again. 10 minus 8 times 2 should equal 2, 5 minus 4 times 2. All right, so let's go ahead and do our stuff here. Again, I'm going to solve the whole left-hand side first. So 10 minus 8 times 2, that's 10 minus 16. 10 minus 16 is negative 6. Now I'm going to come over here and solve my whole right-hand side. So 2, nope, first I got to multiply this 4 times 2 here. So 2, 5 minus 8. And then we're going to solve what's in parentheses. 5 minus 8 is -3, and then 2 times -3 is -6. So we did get the same answer here, -6, -6. We could do this again. I'm going to erase this and actually do a whole new equation here. So that time we plugged in 2, we got it to equal each other just like we should have. Now what happens if I plug in, let's say 0? So 10 minus 8 times 0 equals 2. 5 minus 4 times 0. And let's solve. So 10 minus 8 times 0 is 0. 10 minus 0 is 10. Come over here and we'll do this again. Let's see. 4 times 0 is 0. 5 minus 0 is 5. And 2 times 5 is 10. 10 and 10, we got the same answer there. So again, we come up with, it's the same solution. No matter what number we plug in for A, we're always going to come up with the right and the left matching each other. That is infinite solution. Now finally on down to no solution. Again, we're just going to start solving this just like we would solve any other problem. This time we do need to combine here on this right hand side. So since I'm not messing with the left hand side yet, we're just going to bring it straight down. And then I've got 7m minus m here. So 7 minus 1, because remember there is an invisible 1 there. 6m plus 7. And then we're going to start moving our stuff around. So minus 6m from this side, minus 6m from this side. This is 0, and I have a -5 left over here. And this is also 0, but I have a 7 over here. So in this case, we lost our variable, but our numbers don't match each other. They are not equal to each other. So in this case, there are no solutions. It doesn't matter what number I plug in here. I am never going to come up with those two numbers being the same, no matter what I do. And we can check that. Again, we'll just pick a random number. We're going to pick 1 this time. So if I do 6 times 1, I forgot to change my color. I know it doesn't matter. I just like consistency. So 6 times 1 minus 5 equals 7 times 1 plus 7 minus 1. And we're just going to solve. Just like before, I'm going to do everything on my left-hand side first. So 6 times 1 is 6 minus 5. 6 minus 5 is 1. On the right-hand side now, 7 times 1 is 7 plus 7 minus 1. 7 plus 7 is 14 minus 1, and 14 minus 1 is 13. So not equal to each other. We can try this again with 0, or really any other number. I just like to go 0 because it's the easiest one to plug in. So 6 times 0 minus 5 equals 7 times 0 plus 7 minus 0. So 6 times 0 is 0 minus 5. 0 minus 5 is -5. On the other side, 0 plus 7 minus 0. 0 plus 7 is still 7, and 7 minus 0 is still 7. And again, they do not match. We're never going to find a solution that matches, so no solution.